Good morning, students. Welcome to Investigation 12, 52220. This is your last regular math lesson. All right, and we are learning about tessellations. All right, archaeologists people that have been making or using tiles to make mosaics and decorate homes and other buildings since about 4000 BC. The Romans called these tesserae, from which we get the word tessellation or tiling. A tessellation is the repeated use of a shape to fill a flat surface without gaps or overlaps. That is an important factor. You cannot have gaps or overlaps. So here are some examples of tessellations. All right, in this example, we have what you can see right away are equilateral triangles. In this example, we have squares. So a regular tessellation is a tessellation made with regular polygons. All right, some shapes tessellate and some do not. All right, now regular polygons that do tessellate are triangles, squares, and hectagons. So as we look at these shapes and at these regular regular polygons, we know that the shapes can vary. So as we see right here, this triangle, when it moves, when it tessellates, it turns 180 degrees. So it rotates. This triangle rotates for this tessellation, correct? So as we look at this, it makes a half of a turn. A full turn would be 360 degrees. A half of a turn is 180. All right, now we're going to look at the vertex. So I am going to point to the vertex. Our first question asks us, how many triangles meet at each vertex in figure A? So as we look, we go 1, 2, 3, 4, 5, 6. Now, as you're looking at the shape that I see a shape coming out of this. And it has 1, 2, 3, 4, 5, 6 sides, and it is a hexagon. We will be referring to that later but yes, so a hexagon is also a regular polygon that tessellates. All right, how many squares meet at the vertex? So here we go. I put my mark on the vertex. 1, 2, 3, 4. 4 squares meet at the vertex. All right, let's go on to the next page. So here is a regular polygon, a pentagon. It's called a regular polygon because all of its sides are equal and its angles are equal. So guess what? This 5-sided shape does not tessellate because you can see there are gaps. When it comes together, it just can't fit together without gaps. Now, we'll talk more about this later, but some tessellations take other shapes that can go with them to help them create a tessellation because they can fill in the gaps with a different shape, such as maybe a triangle there, all right, to form a tessellation. So we see that the regular polygon on the left will not fit into the gap formed by the other pentagons. Therefore, a regular pentagon does not tessellate. So, which of these polygons tessellates? And then it says draw a tessellation that uses that polygon. I will show you some tessellations that use that polygon on the last page. All right, so we already know, just from our previous example and what we were looking at, that the hexagon is a regular polygon that makes that tessellates. So here we have an octagon that does not naturally tessellate. Here we have a decagon, 10-sided shape, and our pentagon. All right, so our regular polygon that tessellates is our hexagon. So there are some combinations of regular polygons that tessellate. All right, so here we go. We have hexagons and equilateral triangles that come together in this shape, right? As we already looked at in our other example. and we will have more examples of this. So a tiling composed of 2 or more regular polygons is called a semi-regular tessellation. So a regular tessellation is just one shape, regular, just tessellating over and over again, all right? So which 2 of these regular polygons could combine to tile a plane? All right, so which 2 could come together? So this is an octagon, correct? And this one is 1, 2, 3, 4, 5, hexagon. This one is a square. This is a decagon. So guess what? What 2 could come together to create a shape? Well, I will show you on the last page how we can bring different shapes together. But you could take your octagon and you could put the square on it. You could add a square as part of the, to get those to come together. All right, to get them to make another shape. You could put a square on this end, then put another octagon on here for your sides, and your shape could tessellate. So you can combine shapes to make, if the shape doesn't naturally tessellate on its own. All right, many polygons that are not regular polygons can still tile a plane, but we'd have to add other shapes with it. So here we go. Notice that both of these examples, we have triangles, that the tiles are congruent, but that the alternate tiles rotate, all right, 180 degrees. So as we've talked about before, here we have, and the tile rotates, it turns. So the point here is up here, the point there. Same with this quadrilateral, which means 4-sided shape. So this here, then it flips, or it rotates actually, it doesn't flip, it rotates. Here we go, the pattern just keeps repeating. All right, so in this part of our lesson, activity 1, we're not going to do any other activity other than this one. We'll talk about the bottom one, but in this one, we are going to carefully put together the shapes. First, we'll start with the triangles. It says carefully cut out the triangles. Why do you think it says carefully cut out the triangles? Because if you weren't careful about it and you were sloppy, your shapes aren't going to fit together without gaps or overlaps. So I'm going to slide the iPad up here. We will need it again, but here we go. Here we have my shapes that I cut out. So in order to put these together, as you can see, all right, I have my triangle or my right angle. Then I need to put these together without gaps or overlaps. So there we go. I rotated that one. Now I'm going to put this one here. I'm going to have to rotate it. Here, I need to flip this. There we go. Much better. Now obviously when you're handling the paper, it's a little harder to make it not gap or overlap, but normally if I were in school, we would just be taking these tessellations, putting them together, and then we would be making some design with them and we would tape them together. But I am trying to have no gaps or overlaps. All right, so here we go. And we'll put one more piece on there. All right, so as you can see, what we did with this one is, the shape would rotate 180 degrees, just like it did on the other one. Now we'll grab some of our quadrilaterals that I cut out carefully and put these together. All right, so the shape that we have a diamond, and we can go like this to create our tessellation. Put those two together. All right. Obviously I have gaps still. It's not, I need tape. There we go. It's coming together at least a little bit better. Then I come in here with this shape. Then I come in here with this quadrilateral or parallelogram, and I could keep repeating the pattern. All right. And one of the main things that I need to make sure is that I have no gaps or overlaps, right? It is not as easy as you would think. But, all right, I am going to show you some examples after we discuss this last piece on the page. All right, so at the bottom of the page, you can see that you can take a polygon and you can alter it. So they take this equilateral triangle and then they alter it. They rip the bottom off, all right? So then they tape it to the side here. As you can see, they taped it to the side, and then they tessellate them. They fit them together. All right, so I'm going to show you some regular, here we have, so as you can see, here we have the pentagon again, how it doesn't fit together well. It leaves gaps, right? So here we have a regular hexagon, and this is the regular hexagon that that fits together beautifully, that tessellates perfectly and creates this beautiful pattern. It almost looks like a flower. Here we have equilateral triangles that tessellate, correct? And they are rotated 180 degrees. And here we go again, we have a hexagon within this. So this is called a semi-regular tessellation because it has hexagons and triangles. And here we go. We have just squares, regular squares that are tessellating. Now, when you look at this, if you alternated the color, there are many things in life that tessellate, many shapes, many things. When you come to the meeting today, I want you to have some examples. All right, and then here we have where we have put it together hexagon and triangles to create a tessellation, to make this beautiful pattern. All right, think about where you see these patterns in the world. All right, when you come to the meeting today, we'll discuss it. Think about where you see this type of pattern, this type of pattern. All right, these different types of patterns. Tessellation, we will discuss more, is definitely an art form also. So it correlates between math and art, and it can be very fun to do. So I look forward to seeing you in math class today, and we will talk more about tessellations. You do not have to do any of the other pages in this lesson. All right, have fun with it.